In this lesson, we're going to introduce what's called the side-side-side congruence postulate regarding triangles. Okay, so this is triangle ABC, and this is triangle DEF. Let's go ahead and write that out. So this is triangle ABC, and this is triangle DEF, okay? And you can see that this side right here corresponds to this side, okay? And that this longer side right here corresponds to this longer side, and that this medium size corresponds to this side right here, okay? That's important, okay? And so here's what the side-side-side congruence postulate says, and it's often abbreviated as SSS, okay? What it says is this. It says if each side of a triangle, okay? And so here's a triangle, and each side, we have a side here, side, we have a side here, side, and we have a side here, side, okay? If each side of a triangle is congruent to its corresponding side of another triangle, okay? So what we're saying is if this short side is congruent to this side over here, that's how we show congruence sometimes, is we put slashes through two sides of geometric figures to indicate that they are congruent. So if I put a single slash here and I put a single slash here, it means that those two sides are congruent. Okay, so if the first side, the shorter side, is congruent to its corresponding side in another triangle, and the medium side is congruent, so what we'll do is, to distinguish, we'll put two slashes through the next one. So if the medium side is congruent to the medium side in the second triangle, and then we'll put three slashes in the long side. If the long side of ABC is congruent to the long side of DEF, then what we say is that the two triangles are congruent to each other. So if the short side is congruent to the short side of DEF, and the medium side of ABC is congruent to the medium side of DEF, and the long side of ABC is congruent to the long side of DEF, then we can say that then triangle ABC is congruent to triangle DEF, and then we would say by the side-side-side postulate, by the side-side-side postulate, we can say that these two triangles are congruent. What does it mean for them to be congruent? Well, that means that if this side, if the short side of ABC is equal to 12, then the short side of DEF is also equal to 12. If the medium side of ABC is equal to 19, then the medium side of DEF is also equal to 19. It's the exact same number. If the long side of ABC is equal to 25, then the long side of DEF is also equal to 25. And so when the measures are the same, that means that the sides are congruent. And if all three pairs of corresponding sides are congruent to each other, then that means that the two triangles themselves are congruent. Let's look at some examples of how we can use this postulate. So here we have triangle ABC, and here we have triangle DEF, okay? And we want to know what it would take for triangle ABC to be congruent to triangle DEF, okay? So how can we show that triangle ABC is congruent to triangle DEF? Well, let's suppose that side A here is equal to 23. And let's suppose side B is equal to 31. And let's suppose side C is equal to 44. Well, we could then say that ABC is congruent to triangle DEF if side D is a certain measure, side E is a certain measure, and side F is a certain measure by the side postulate of congruence. Well, what this means is side D would need to be congruent to its corresponding side in this triangle ABC. Well, D looks like it's smaller than F, but it looks like it's longer than E. So I think D is the middle length side. And over here, it looks like B is the middle length side. So if D is congruent to B, then it's possible that triangle ABC will be congruent to triangle DEF. Well, what does it mean for D to be congruent to B? Well, B is equal to 31, so if D also equals 31, then it's possible these two triangles could be congruent. Well, now let's try side E. Well, side E looks like the shortest side, and over here side A looks like the shortest side. So if E is congruent to A, then it's possible that ABC will be congruent to DEF. Well, A is equal to 23. So in order for E to be congruent to A, E would have to be equal to 23. So we're going to put a 23 here. And then lastly is side F. We have two sides that are congruent to the other triangle. Now we need the third side to be congruent. So F would have to be congruent to C. And so we're going to put a triple slashes here, triple slashes. So what does it mean for F to be congruent to C? Well, C is equal to 44. Then F would have to be equal to 44. So we're going to put F equals 44. And so now, since the three sides of ABC are 23, 31, and 44, then if the three sides of DEF are also 23, 31, and 44, then by the side postulate of congruence, we can say that triangle ABC is congruent to triangle DEF. Let's do one more example. Okay, so over here we have triangle ABC, ABC, and over here we have triangle ADE, ADE, okay? And we have the sides. We have sides A, B, and C, and sides D, E, and F. Okay? And it says that suppose that A is 17, B is 24, and C is 13. Well, then triangle ABC will be proved congruent to triangle ADE if D is equal to a particular measure. Well, here's D, and it looks like D corresponds to side B. And so if side D and side B are congruent, then this congruence of the triangles could be true. Well, how can we show that D is congruent to B? Well, D would have the same measure as B, which is 24. So if D is equal to 24, then it's possible that these two triangles could be congruent. All right, what about E? Well, E looks like the shortest side of ADE, and C is the shortest side of ABC. So then if E is congruent to C, then it's possible that these two triangles are congruent. Well, C has a measure of 13, so if E also has a measure of 13, so we'll put 13 here, then it's possible that these two triangles are congruent. So we have two sides that are congruent. So now we just need a third side that's congruent. Well, F looks like the longest side, and so does A. So if A is congruent to F, then we can show for sure that the two triangles are congruent. Well, A is equal to 17. So if F is also equal to 17, then F and A will be congruent. So we'll put a 17 here, okay? I want you to notice that B and D are actually the longer sides and I put 2 slashes, we don't always put I know in the last 2 examples, I put the 3 slashes on the longest side. It's okay to put the 3 slashes on not the longest side. It's okay to put 2 slashes, okay, as long as you're putting them on the sides that are corresponding and congruent to each other, okay? So if D is 24, E is 13, and F is 17, also B is 24, C is 13, and A is 17. Therefore, by the side postulate, we can prove, or we show that triangle ABC is congruent to triangle ADE.